Okay. Good day, everyone. So today we're going to continue our discussion about uh, sig- chapter one, which is the units physical quantities vectors in the University Physics with Modern Physics 15th edition. So we are now going to answer example 1.3. So here, this is about how to use significant figures in calculations. So here, specifically significant figures in multiplication. Okay. So the rest energy E of an object with a rest mass m is given by Albert Einstein famous equation, which is E is equal to mc squared, where c is the speed of light in a vacuum. Find E for an electron, okay, for which three significant figures, the mass is equal to 9.11 times 10 to the negative 31 kilograms. The SI unit of E is joules, or 1 joule is equal to 1 kilograms meters per second squared. Okay, let's answer this problem. Okay, so before that, let's have a walk through. So I get this from the Young and Friedman book, University of Physics with Modern Physics 15th edition. This is the rules on how to use the how to determine the correct significant figures of your final answers if you're using significant figures in your calculations. Okay, if you do multiplication such as this, so multiplication or division says that your final answer must have results, or your results must can have no more significant figures than the factor with the fewest significant figures. Okay, so let's try that one. So you have 0.745 times 2.2 divided by 3.885 times 2.2. Okay, so your answer here is actually 0.42187902188. So however, since this is multiplication or division, our results can have no more significant figures than the factor with the fewest significant figures. The fewest significant figures here is 2.2 because it has two significant figures. We have three significant figures and we have four significant figures. Again, you need to review your how to determine the number of significant figures. Okay. So that's why instead of writing this long these numbers here with so many digits, so we choose only two significant figures. Okay. This one, okay. I mean 0.42. So that's why that's the final answer. Okay. So one thing you remember, class, in answering problems is that this is the results, final results. But sometimes you need to in chemistry especially, there are intermediate calculations such as, for example, uh, some of us, what do I mean is that intermediate result, for example, instead of doing this in a calculator, you do this first, okay, 0.745 times 2.2, okay, what would be the answer? Times 2.2. So here you have 1.639. Okay. Okay. This, I just want to point out this because it's very important. Okay. So what happens here? If you apply the this rule right away, So you have 1.6. Okay. So 1.6 divided by 3.885, what would happen? So you're gonna get uh, 0.411. Okay. 4118 like this. 4. Okay. Then your final answer is 0.41. Okay, so different. Okay. Uh, what should we do in this particular case? Okay. So this, remember, this is the final result, or the final result. So when you do an intermediate result, calculations that will give you intermediate results, uh, don't apply yet these rules. Okay, get as much as get as much significant figures as you can have like this. If possible, include this one. Okay, instead of using 1.6, you use 1.639 over 3.885. Okay, 1.639 over 3.885. Okay, so that you can have 0.42. Okay, so again, if you are using, you are you do an intermediate calculations and you're given an intermediate result like this, don't apply these rules first. Get as many digits as you can. So maybe up to 5 significant figures, or up to 5, or maybe as significant as you can, to cover as much as uncertainty as possible. Okay? And then only apply these rules in your final results. Okay. So those are the thing that you need to remember, uh, because you might encounter that in your future study in physics. Okay. Let me erase this one. So much for this. Okay. So, so again, if you do also the calculation here, it will give you, okay, let's do this one first. 1.32578 times 10 to the 7 times 4.11 times 10 to the negative 3. So it give us 54489.558. So, however, if you look at the least significant, if you look at the factor with the fewest significant figures, it has only 3 significant figures. So our answer must be also in 3 significant figures. So we can put this one, you can use scientific notation, 5.4, okay, round up, 5 times 10 to the 1, 2, 3, 4, 4. Okay. How about addition and subtraction? The rules in addition and subtraction is that the number of significant figures is determined by the term with the largest uncertainty. What is that? Or in another sense, you just look at the fewest digit, or meaning the fewest digits to the right of the decimal point. Okay, you just look at which of them, which of the given has the fewest digits to the right of this decimal point, then your final answer should be like that. Okay. So in terms of largest uncertainty, okay, so you must read or refer this one to your book and to the discussions of your instructor in the lecture. Okay, to give you a hint of this, So most of the uncertainties will not be explicitly told to you. Okay, you will know the uncertainties of the number based on the significant number of significant figures. And because of uncertainties in the experiments of your results, and if you add and uh, multiply your results, so your results have uncertainties. That's the meaning of that, or meaning error. So if you add, divide, subtract, so your answers or your results might have uncertainties or errors. Okay. How, okay. What do you mean by large uncertainty? Okay. So you can know the uncertainty of this as 0.001. This one is 0.1. Okay. 0.01. Okay. So here, the largest uncertainty is this one, 0.1, compared to this two. That's what they mean. Again, refer and read your book so that you can fully understand this concept. But for now, the easiest way to do is just to the look at the given. Which of them has the fewest digits to the right of the decimal point? Then your answer must be on that form also. Okay, let's do the calculations. So we have 153.613. So but however, our results must be the same to the given with the largest uncertainty or the fewest digits to the right of the decimal point, then our answer must be 153.6. Okay, this one. Okay, so knowing this, let's look at the problem. Okay, the rest energy E, so we have read this one already. So we need to find E is equal to mc squared. You need to find E. So solution, E, this is equal to mc squared. So which is equal to 9.11 times 10 to the negative 31, okay, kilograms. Okay. And the speed of light, 2.99792458, okay, times 10 to the 8 meters per second. Okay, this is squared. Okay, forget about this. Then our since our significant figures, the factor with the fewest significant figures is this one with just three significant figures. Therefore, our answer must be in three significant figures also. So do the calculation times 2.999 the 8 squared. So we have in three significant figures 8.19. So what's the unit? Joules, kilograms, meter squared per second squared, or I mean, sorry, times 10 to the negative 14 kilograms, meters per second squared, or 8.19 times 10 to the negative 14 joules. Okay. So if you want contents and more videos like this, please click subscribe, leave a comment, and like our YouTube channel. See you in the next videos.